Excuse me. Okay, let's take a look at our schedule. We have our last lesson today. Conceptually, what we talk about today is going to be on the final, but we're going to do some stuff with graphing calculators, and you will not have to know how to do the stuff with the calculator for the final. But I think that the stuff that we do today is going to help you sort of big picture think about functions and different kinds of functions and modeling. Okay. So don't forget, project 5 is due today. The give an example of project, put that in your folder before you leave. If you hand it in Monday, if it's not done, you'll still get, you'll just get a 10% penalty. And that's it. Okay. So let's look at today's lecture. Okay, so we're going to talk about data fitting. So I've written out the general process for you for how to perform regression on a TI. We've done this twice before. We did it with linear regression and we did it with polynomial regression. But now we have several other kinds of functions that we know about. We now know about exponential functions, logarithmic functions, and logistic functions. So we didn't talk very much about it. We introduced them last class. That's the one with the like increase and then levels off at a carrying capacity. All right, so that's the procedure for how you do it. If you can't remember, you can refer to that later. I'll show you one example also before I let you start. Some words to live by when you're creating a mathematical model. Words to live by, yeah. The more data, the better, right? A model with very few data points is not very reliable. And if there's a theory-based reason to go with a particular kind of function, for example, projectile motion, like when you throw something up in the air, that is quadratic based on Newton's theory of gravity, etc., right? Yeah. So we typically use quadratic for that. Even if it's not a perfect fit, we use quadratic because theoretically that's what it is. A simple model that fits the data reasonably well is usually preferable to a complex model that fits only slightly better. So we prefer something that's simple, even if it's not perfect, to something with a lot of complexity that's only a little bit better. And generally, using a model to interpolate, which means finding values between known values, is much more accurate than using them to extrapolate, which means finding values outside of the data set. For deciding on a type of function, first thing you do is look at the scatter plot and just say, does that look like one of the kinds of functions I know? Sometimes it's not clear what function might best model the data. You might say, well, that looks like it could be quadratic or it could be exponential. I can't really tell. So what you do is you just try a couple of different kinds. Do it more than once. Your calculator does all the work, so you can just try more than one. You can see which one fits better visually. Graph your regression curve over your data, see which one looks like a better fit. Or you can compare R-squared values. Okay? That's the statistic what your calculator tells you. The closer to 1 it is, the better the approximation of the data. But don't forget, complex models will generally have higher values of R-squared, but we like simple models, right? The simpler the better, with a reasonably good fit. If your R-squared doesn't appear, there are directions for how to make R-squared show up on your calculator right there. So that's your page of intro. This is just a handy little reference about what kind of model, what some pictures might look like, and what kind of model you would choose for them. So if all your data falls in a line or something close to a line, you'd use a linear function, and that's linreg in your calculator. If you get a U shape, you might use quadreg, right? If you have more than one turning point, if you have 2 turning points like that, or it might not even have any relative extrema, but it's not linear, right? It has this like flattening out thing that could be cubic also. 3 extrema, you'd have to use a quartic. Exponential is just going up, right? So you can see why exponential and quadratic might get confusing, right? If you only saw the right half there, you might wonder whether that was exponential or quadratic or linear even. So exponential can look like exponential growth or exponential decay. And then logarithmic is growth, but it's much slower. And then logistic has the classic S-shaped curve. That's kind of the one that's the easiest to pick out, I think. Just know the TI does not give an R-squared value for logistic regression. I don't know why. It just doesn't. So you'd have to inspect visually to determine if it's a good fit. You'll have to graph your model on top of your data, see if it looks good. Okay, let's just do one together. I'll hand out some calculators so that you can try to follow along. Okay, so I've got a random set of data here. This has no context, so we're just going to go strictly visually on how we choose our model. Some of the problems later have some context, and that might determine what model you choose. Okay. So I'm just going to enter my data. So if you remember, you do that by pressing stat. Stat button is like center near the top, right underneath delete. Choose option 1, edit, and your lists come up. I just pressed enter. Yeah. Your lists come up. If there's data in there, you're going to want to clear it. You clear data by highlighting the name of the list. Just use your cursor to go up and highlight the name of the list and press clear. It appears like nothing will happen, and then when you move your cursor down back into the list, everything goes away. So do that for both your lists, so everything's empty. And then we just start entering our data. Put the X data in list 1 and the Y data in list 2. All right. When you have all your data entered, one quick check that it doesn't guarantee that you have no typos, but one thing you should check is that your two lists are the same length, right? So that each X is paired with a Y. It's possible you made a typo somewhere, but it's really common to just skip a whole X value or something and end up with lists different lengths. All right, so all of our data is in there. Okay, so I'm just going to quit out of the screen, go back to the home screen. You hit second quit. So quit is written in yellow right above mode next to the second button. So we're back in the home screen. Now we want to perform, okay, so the next thing I want to do is look at a scatter plot because I have to decide what kind of model is going to model that data well. So I want to look at a picture of it. So I'm going to go to y equals. If there's anything in there, clear it. Clear, clear. And you want to turn plot 1 on. So plot 1 up in the upper left needs to be highlighted. Put your cursor on it and press enter. Make sure it's highlighted. Nothing in any of the y equals, just plot 1. Okay. Once you have that done, we're going to have the calculator choose a good window based on the data by pressing zoom 9, I think. Yeah, zoom 9 for zoom stat. Yep. Or you can just press the number 9, either way. Okay, so we go back to our graph. What kind of function does it look like I could use to match that data? Exponential, sure. It definitely looks like it starts growing slowly and then gets really fast, which is classic exponential. All right, so I quit, go back to my home screen, and I want the calculator to find an exponential equation that goes through that data. So I go to Stat, and this time instead of Edit, I'm going to move my cursor over to Calc for Calculate. And then we scroll down until you see EXPREG, Exponential Regression. 0, right after number 9. Oh, good. Okay. All right, exponential regression. And then if you have an older calculator, this is going to pop up. If you have a newer one, which is most of you, it's going to prompt you. Where is your data? You have to tell it list 1 and list 2. That's the default. And then where do you want to store the data? It says STO reg ec for regression equation, store regression equation. You want to put that in Y1. So in my older calculator, I have to type list 1, comma, list 2, comma, Y1. I just have to know that that's what it wants. In the newer ones, it prompts you. To get Y1, you press vars, cursor over to yvars, choose option 1 for function, and then choose Y1 or wherever you want to store it. And then you got to highlight calculate, I think, and press enter. Yes. Okay, so my calculator gives me, it says the form of my model is a times b to the x, and it gives me the value of a and the value of b, and it gives me an r squared value. Okay. So my function is going to be y equals a times b to the x, where a is 1.179 times b, which is 1.265 to the x. So that's going to be my model. When you're writing down the equation, like in your activities, when you're writing the equation down, you can just do 2 or 3 decimal places. And then if you're going to use your model for something, it's pasted in Y1. So you can plug numbers in using your table or solve things graphically if you want to. All right, and then let's write down our r squared value also. R squared is about 0.98, which is really good, really close to 1. So, and if I press graph, because I had it pasted into Y1, when I press graph, it's going to graph on top of my data. So we can also visually see that it's a very good fit. R squared tells us it's a very good fit, so does the visual. I don't know. Oh, sure. There could be data that has a perfect fit. Yeah. Yep. You didn't get an r squared? Okay. If you don't have r squared, I'll walk you through the steps. It's written in your notes a little earlier. But if you didn't get an r squared, you go to catalog. It's second 0. Scroll down until you see diagnostic on. And it's alphabetical, so you just got to scroll until you get to the D's. Diagnostic on. Press enter, enter. And now if you redo your regression, you should get an r squared value. Quick way to redo your regression is to hit second enter until it comes up, and then just press enter. So how do I get back to the after diagnostic? All right, so this we would say appears to be a good model, right? And that's all they asked for in this particular question was write down your equation and value of r squared. Okay, now you can try some on your own. Let me know if you have questions. Okay, so I just want to say a few things about the final exam so that you know what you can do over the weekend to prepare. You have a study guide at the end of packet 4. So as soon as you turn the page from today's lesson, it'll be the study guide. There's a whole list of things you should be able to do. And then resources include your old tests and quizzes. Review problems from in my math lab. There's a final exam review in my math lab. Old homework assignments, because you can always click try a similar problem as many times as you want. So that's an unlimited resource of review problems. I gave you 2 worksheets as part of this study guide. They'll give you practice with some of the important skills on the final, but not all of them. So definitely do those, but they shouldn't be the only thing you do. You can use a scientific calculator, and like I said last class, I will have a few calculators, but because the whole math department is giving finals, I may not have as many as I usually do. So whatever you can do to bring your own would be really good. You can bring 4 pages of notes with you to the final exam, front and back.
Wait, so those 2 review worksheets are those on the middle?
They're in the next page of this packet. There's one.
Oh, so like they're like what we usually have.
Yeah. Yep.
Where is all this?
This is in that packet. Yep. Just turn the pages and you'll see all this. Yep. Yep. So all of this information is in your packet. The types of problems to expect on the final. There's going to be a section of problems that are like, give an example of a function that has such and such properties, which is just like Project 5. And you've had some of those on every test and every quiz, so you got lots of those to practice. There'll be a whole section of solve these like 8 equations, and we can do, well, there's all different kinds now.
12 is what is it? 80 equations.
8. 8. Here are 8 equations, solve them. Right. And then there's going to be a section of what kind of function is this, where I might give you a picture of a graph, or I might give you some data like in a table, or I might give you a verbal description about a ball falling or something like that. And you have to say what kind of function it is and be able to find a formula. There's going to be a section of word problems. There's going to be a couple of other miscellaneous sort of thematic function questions like composition, inverse, maybe interpreting function notation in a contextualized problem, like what are the inputs, what are the outputs. Yep, 7 pages, 8-ish questions. So you have a lot of practice with most of the kinds of questions that are going to be on here. We've got a section of equations to solve, and I gave you a bunch of practice equations, right? And then you've got a section of word problems, and you've got several word problems to practice with here. And then you have a section of come up with what kind of function is it and find a formula. So here you have a worksheet to practice that. You've got a bunch of pictures of graphs, and you want to be able to look at, say, this middle graph and go, oh, that's definitely exponential, and then find a formula for that graph.
Do these have the video?
These all have videos, yeah. Those are in, the link is in Moodle. They're in YouTube. Yeah, so that's it. And they all have the answers, your answers here. And yeah, I don't think I have anything else. Again, there's a big review in my math lab too if you need more practice problem review.